We're getting asked to analyze the truss from the previous problem, so we know all the reaction forces at the supports from before. But now we're asked to find some loads in some other members from F to G, DG, and FF. So basically, instead of here, we're looking at a little bit over here. And so we should see a little bit different. So again, we can write our forces in terms of magnitudes and directions. Okay, so here's the unit vector from F to G, from F to H, from D to G, which is just in the x direction. Again, we can write these as in vector form because those are just in the horizontal vertical directions. And then we can sum up the forces. So we have all of these forces and all of these forces, and those have to sum to 0. And then we'll take moments about point B, and I wrote it out here explicitly. Moments that act through point A are F1 and FDG. Act through from position D is F2, so R to D is this vector. And to position F, which is here, which is this vector, again we can write that because we know the distance, the vertical and the horizontal distance to that point. So that's that, and then we can set that equal to 0, and this will give us one equation. Just the outer plane component will be non-zero, and this will give us 2 equations, and we can use those 3 equations to solve for these 3 unknowns here. And we get FDG is minus 18.75 kips, FFG is 14.03 kips, and FFH is 17.43 kips. So let's see, FDG is minus 18.75 here, and here AD was minus not nearly as much. So that's about what, 4, about 3.5 maybe, minus 3.5, and here we're already up to 18, well, close to 19. So the stress in here is a lot more compressive than it is in here, and that's mostly probably due because this force here is acting to stretch this guy much more than this stuff over here is carrying this load much more than this stuff over here. So we'd probably get a larger compressive stress in this member if we were asked to calculate it. It'd probably be lower than this, I suspect, but higher than this.